Volcanoes form one of the important endogenic movements of the earth. Both volcanoes and earthquakes are the two important forces coming from below the surface of the earth, and they are engaged in destruction. However, compared to earthquakes, volcanoes are both destructive as well as constructive. On one side, they bring destruction accompanying earthquakes with their lava flow and other pyroclastic materials, dust, temperature, which affect nearby biosphere and also man-made structures. Historically, great volcanic eruptions like Vesuvius have destroyed Pompeii city in Italy, and in recent times, Krakatoa in East Indies brought destruction to islanders and kicked off volcanic dust which went around the world for years, affecting solar radiation. Our own lonely volcano of India in North Andamans is known as Barren Islands, which occasionally come to life and wipes out life nearby. However, they are also helpful to man with creating fertile volcanic soil, minerals, emitting chemicals into water, and also some other fertilizer minerals in their region. Most useful aspects of volcanoes to modern man comes from their hot water and steam in the form of geothermal energy. In this episode, let us understand first nature of volcanic activity, causes and landforms built by volcanoes along with their other associated destructive forces as well as beneficial aspects. Also, we must understand their distribution in the world with their aspects of prediction and management, which is also important for all of us. A volcano is a vent or an opening, usually circular or nearly circular in form, through which the heated material consisting of gases, water, liquid lava, and fragments of rocks are rejected from the highly heated interior to the surface of the earth. A volcano behaves like a giant chimney conducting material from shallow depth in the earth up to the surface. When a volcano erupts, hot liquid rock called lava, gases, and rock fragments are spewed onto the surface through its opening. This chimney may take the form of a tall mountain cone. As volcanoes, however, may be a fissure or cracks or slits as in the earth crust through which the lava oozes out many times to produce flat lava plateau. We will be returning to these aspects a little later in this episode with some more details under volcanic landforms. A volcanic eruption starts deep down in the earth's crust or in the upper mantle, the thick mantle underlying layer. Here, rocks melt to form magma, essentially a mixture of volcanic gases dissolved in the liquid lava. Underground pressure from the weight of the surrounding rocks force the magma towards the surface. As the magma wells up some time into an underground reservoir on magma chamber, under the volcano, the pressure drops and gases start to bubble out of the liquid. The gases mainly consist of steam. Most of it comes from water seeping through the rocks of the upper crust to meet the rising magma. They also contain carbon dioxide, nitrogen, sulfur dioxide, and small quantities of noxious gases as hydrogen sulfide and hydrogen chloride. Eventually, magma finds its way to the surface in a volcanic eruption, either through an existing vent or fissure from a previous eruption or by forcing its way up through the cracks in the earth crust. On the flanks around the base of an existing cone, secondary vents or pipes often produce small pimples known as parasitic cones. The main causes for the volcanoes is the movement of the Earth's plates in the form of plate tectonics. The concept of plate tectonics provides an explanation for the volcanic activity and the distribution across the world. The Earth has rigid crust which consists of 6 major plates and over another dozen of minor plates. They are moving freely in relation to each other and glide relatively freely over the Earth's surface. The mantle of the Earth, the layer below the crust, is solid and its temperature is normally not high enough to start the melting which forms magma. Lower pressure in these places allow the hot mantle to melt and produce magma. This rises and forms new oceanic crust and volcanoes at the plate margins. Iceland is an area that experiences this process. A detailed explanation of plate tectonics reveals that at convergent plate boundaries, destructive plate margins are usually at oceanic boundaries, such as the trenches around the Pacific Ocean, which is also known as the girdle of fire or the ring of fire. The edge of this plate is forced beneath that of the another, which is subducted. The oceanic crust is carried down into the mantle and starts to melt. It often rises and heats the overlying continental material and may cause further independent melting. These various kinds of magma reach the surface and produce different types of volcanoes, mostly very violent in nature. They can be seen around the perimeter of the Pacific Rim and in the island arcs of Indonesia, West Indies and Japan. Hawaii, lying in the center of the Pacific plate, does not fit this pattern. The islands are thought to overlie a hot spot or plume of rising mantle which provides the magma for eruptions. Volcanoes are classified broadly based on their mode of volcanic eruption and their periodicity. Now coming to the first, a classification on the basis of the mode of eruption. We have Hawaiian type, Strombolian type, Volcanian type, Pelian type, Vesuvius type, along with the Fisher type of volcano belong to a sort of explosive type of volcanoes. A classification on the basis of the periodicity, volcanoes have been classified as active volcanoes, dormant volcanoes and extinct volcanoes. Coming to some amount of details of the first explosive type, the Hawaiian type, they erupt quietly but with some explosion is there, and they explode due to less viscous lava and non-violent nature of gases. It forms the largest volcano in the world along with an active but calm type of eruption like Kilauea. Now under this you also have Strombolian type, which are moderate in the nature of eruption, which are named after Stromboli volcano of Lipari Island in the Mediterranean Sea. The eruption are almost rhythmic and nearly continuous in nature, but sometimes they are erupted by long intervals. Pelian type of volcanoes are the most violent and most explosive type of volcanoes. Each successive eruption come with great noise and viscous lava and other pyroclastic materials are thrown or spewed out of the volcanic vent. Also in this explosive series we have Volcanian type, or also known as explosive. They contain lavas are so viscous that these are quietly solidified and hardened between two explosions. Thus the crust over them as the escape of violent gases during next explosion Consequently, during the next explosion, a violent explosion shatters lava crust into angular fragments. Even cauliflower shape of clouds with volcanic dust and rain accompany explosions of this kind. Some of the Mediterranean volcanoes, Rocky Mountain volcanoes of USA belongs to this category. Now under this series also you have Vesuvian type as a volcanic type, very explosive one. These volcanoes are more or less similar to Vulcanian and Strombolian type of explosive volcanoes. They are extremely violent due to violent explosion of magma accompanying explosive gases. Volcanic materials are thrown up into greater height into the sky. The most explosive type of volcanoes known as Plinian type, because such explosive outbursts as he sends volcanic dust to form clouds still greater heights in the sky. Now, after knowing the explosive type of volcanoes, let us come to other types of volcanoes which are classified based on the mode of occurrence, namely fissure type of volcanoes. Fissure type of volcanoes have occurred in the geological past along a long fissure in the earth crust. There is a slow upwelling of magma from below the surface, and lava spreads layer after layer to form as extensive lava plateaus. Now let me come to the other classification of volcanoes, that is classification of volcanoes based on the periodicities of eruption. Based on the period of eruption, volcanoes are divided into active volcanoes. These type of volcanoes are constantly eject volcanic lavas, gases, ashes and other pyroclastic materials. It is estimated that there are about more than 500 active volcanoes in the world of this kind. The second under this category is dormant volcano, or those which become quiet after their eruptions for some times, and there are no indications of any eruption for some time, and suddenly they become active. These bring enormous damages to life and property. Mount Vesuvius of Italy, which erupted in 79 AD, which virtually destroyed the Pompeii city. In India, we have barren islands, which came to life often. In fact, in 1997, there was an eruption, I should say. There are plenty of this kind of dormant volcanoes around the world which come to life occasionally. The last category of the volcanoes under this kind of periodicity classification is extinct volcanoes. Extinct volcanoes are the one which have not erupted in the human history. The sites of past volcanoes, but there are no indications of future eruption. Their crater filled up with water and lakes are formed. In Alaska, Japan have such sites of extinct volcanoes. The very famous extinct volcano is Eiffel, it is in Europe, is considered also as one of the dead volcanoes of the world. However, that no volcano can be declared permanently dead, as no one knows what is happening below the ground. Anytime it can come to life. But these are not active since human history. Volcanic activity produces landforms both on the Earth's surface as well as also below the Earth's surface. The first type, extrusive volcanic landforms, consists of volcanic cones, depressed forms like craters and calderas. Also under the extrusive types, we have fissure volcanoes forming lava plateaus, domes and plains. Under the intrusive landforms of the volcanoes, one can see the batholiths, laccoliths, sills, dikes, volcanic plugs, and stacks. Now coming to those elevated landforms, accumulation of lava related to fragment materials, dust and lava produces different kinds of extensive volcanic landforms like cinder or ash cones, composite cones, lava domes, lava plugs. The accumulation of finer to coarse volcanic materials in and around leads to different shapes of volcanic cones. However, lava domes are formed due to accumulation of solidified lavas around the volcanic vents. A famous volcanic plug in New Mexico state of the United States of America is known as Ship Rock. It rises to a height of 515 meters surrounded by flat countryside. Under depressed landforms, a mouth of the volcano which is called a crater. It is a funnel shaped but slopes of the crater vary. Craters are also vary in size, a few hundred meters to a few kilometers. The Alaskan Angchuk volcanic crater is about 9.6 kilometers long. Whenever crater is filled with water, it becomes crater lake. World's largest crater lake is in Oregon, state of the United States of America, which is known as the crater lake. When a volcano becomes dormant or time being dead, it gets filled up with water and leads to formation of this kind of crater lakes. Several small side craters in a very big volcanic crater is also known as caldera. These calderas are found in Japan and Indonesia, where we have plenty of volcanoes, and some of them have these landforms. Intrusive landforms are created by the volcanoes. During the volcanic activity, the ascending magma often is unable to reach the surface of the earth due to low pressure, from magma reservoir or so. Then magma solidifies below the surface of the earth crust. This cooled magma assumes many shapes and forms variety of landforms. The major ones are batholith, laccoliths, dikes and sills. These intrusive landforms emerge only after the removal of outer layer by years of denudation. World distribution of volcanoes is closely associated with weaker zones of the earth crust, and they have frequent earthquakes also. These are represented by the fold mountains around the world. Number one is Pacific Rim or Circum-Pacific Belt, which I already referred. It is truly known as girdle of fire due to the presence of many active volcanoes in the whole belt, covering Rocky Mountains of North America, Andes Mountains of South America, and islands of Southeast Asia, and also Japan. Apart from this major belt, volcanoes are distributed in the mid-continental belt, which I just now referred. Mid-oceanic ridge belt also has some not so violent volcanoes. First two major volcanic regions have convergent plate margins. The special characteristics of the Pacific volcanic belt is that high volcanic cones and volcanic mountains can be seen with as many as 500 active volcanoes. Cotopaxi of Peru in Andes is the world's highest volcanic peak with 19,613 feet above mean sea level. Mount Fujiyama of Japan, a valley of 10,000 smokes in Alaska of USA, are all in this circum-Pacific belt. The mid-continental belt includes volcanoes of Mediterranean region and volcanoes of fault zones of Africa. In this belt, certain zones and arcs of volcanoes are free from explosives. The mid-Atlantic belt represents volcanoes happening due to divergent plate margins of America and European plates. Some of the volcanoes are fissure type and not violent in nature. For example, Icelandic types like Licky Fisher volcano. There are a few intraplate volcanoes. Volcanic activities in these inner parts of the continental oceanic plates in other than plate tectonic zones. It is believed that pressure of mantle plumes, which are known as hot spots, leads to this kind of volcanoes. For example, Hawaii, USA, and Kamchatka of Russia have such volcanoes. Management of volcanoes. As we have understood by now that volcanoes are both destructive and also constructive forces, modern man, aided with science and technology, seismographic altimeters, GIS and GPS, is monitoring these volcanic regions, particularly USA, Japan, Iceland, Italy, and New Zealand are some of the important countries which are involved in monitoring and management of volcanoes and earthquakes. Volcanoes are seen as resources to promote tourism and generation of geothermal based electricity. Volcanic prediction through ground management, that is the movement of layers, emission of gases, change in temperature of erstwhile volcanoes is being done. No doubt these violent forces cannot be stopped but can be managed to some extent and convert these neutral stuffs or resistances of nature into resources. Friends, in this episode, like earthquakes of the previous episode, which is also closely related to this, we have learned about one of the violent forces of nature, namely the volcanoes. Volcanoes are nothing but the fissures in the earth crust which brings out magma and other a variety of pyroclastic materials. And we have these extensive volcanoes in two belts, circumpacific belt around the Pacific Ocean, which is known as girdle of fire because of presence of over 500 active volcanoes in this zone. And at the same time, as a mid-continental belt also has this volcanoes, particularly in Italy, around the Mediterranean Sea, North Africa, particularly along the fault zones. Volcanoes can be classified in different ways based on their explosive characteristics, but at the same time they are also popularly known as active volcanoes, dormant volcanoes, and extinct volcanoes. These are relative in nature, but some of the dead volcanoes, they can come to life any moment. But time being, from the past over 10,000 years, some of the volcanoes have not become active. Volcanoes, we have understood that they are resources and at the same time they are also destructive forces. When they bring destruction, they also bring some kind of resources in the form of mineral resources. They come out with lots of hot water steam, which are popularly known as geysers. And these thermal waters are helping to generate electricity. Thank you.